6.5 Part 8 is computing work. So you may have talked about this already in physics. It's an application part of it. Okay, so it says the work W done by a constant force F in moving an object from point P to point Q is defined by W is equal to F dot vector PQ, which is equal to the magnitude of F times the magnitude of vector PQ times cosine of theta, where theta is the angle between F and vector PQ. Alright, so look at example 1 here. It said a child pulls a wagon along a level ground with a force of 40 pounds along the handle on the wagon that makes an angle of 42 degrees with the horizontal. How much work has she done by pulling the wagon 150 feet? We want to know how much work she's done. So we know that the work is equal to the force dot vector PQ. Okay, remember vector PQ is the object moved from point P to point Q. Well, we also know from our formula that this is equal to the magnitude of the force times the magnitude of vector PQ times cosine of theta. Well, they gave us this stuff in here. So the work is equal to the magnitude of the force. Well, they told me the force was 40 pounds. So the magnitude of the force is 40 times the magnitude of segment PQ. Well, remember I said that is where it moved from point P to point Q. So how far did it move? That's right here, 150 feet. That is your segment P, or your vector PQ. So times the 150 times cosine, and what angle did that handle make with that horizontal? It was an angle of 42 degrees. Okay, so we can just type this into our calculators and it's going to give us the amount of work she had to do. So 40 times 150 times cosine of 42 degrees, make sure you're in degree mode, and we should get 4,458.87